Ayo. All right, this is the homework solutions video for section 1.4b. I was able to kind of fit about half, a little over half of the problems on this board here. So let's do 27, 29, and 30 real quick here. Those are reading the graphs. It says find the x values at which f is not continuous. Well, it's not continuous at the two vertical asymptotes here. So at -2 and 2. Okay, those are not holes. So that would be a non-removable discontinuity. All right, 29. We have discontinuities everywhere there's a jump, right? So there's a jump. So that's going to be at -1, 0, 1, and 2. Okay, where there's a hole there at 2. So at those jumps, those are non-removable. But it's possible that at x equals 2, that one is removable. We don't get the second half, of the function. So it didn't ask us to say whether it was removable or non-removable, but we do have discontinuities at those jumps there and also at that hole. So again, -1, 0, 1, and 2. And then number 30, the discontinuity occurs at x equals 1 because there's a hole there. But that one you can take a limit and get an answer. The limit would be 1. Your hands come together at 1. So that one is definitely removable. All right, in case, here are the answers to those. In case you weren't able to write them down just because I was talking there. But number 32, all right, that one is 1 over x squared plus 1, right? 1 over x squared plus 1. Well, x squared, you can't ever make that denominator 0. No matter what you put in, what number you plug in, squaring it will become positive. So it's always, you'll never have an undefined area on that function. So it's continuous at all points. Number 33, x plus sine x, there's no denominator there at all. So it's continuous at all points. Same for 34. No denominator, so continuous at all points. All right, 35, 1 over x minus 1. Where is the denominator 0? It is when x is equal to 1. So we have a discontinuity at x is equal to 1. It's going to be non-removable because you can't cancel anything out there. All right, number 36, we have f of x is x over x squared minus 1. You can factor x squared minus 1 into x plus 1, x minus 1. So where is the what values of x make the denominator 0? Well, that's -1 and +1. So there's a discontinuity at plus or minus 1. And because we don't have an x plus 1 or x minus 1 on top, we can't cancel anything out. So both of those discontinuities are non-removable. All right, 37, x over x squared plus 1. Again, just like one we had earlier, you can't make x squared plus 1 0. No matter what you plug in, it's going to be a positive number. So the denominator is never 0, and we are continuous at all points. All right, so pause the video if you need to, and I will erase this and start up with number 39. All right, got those done. So 39. We have f of x is equal to x plus 2 over x squared minus 3x minus 10. Well, let's see if we can factor the bottom. It's a second degree trinomial. So x. How about -5 and +2? If we FOIL that back out, I believe that would work. give us a negative 3x and a minus 10. So our discontinuities occur at the two x values that make the denominator 0. So that would be at 5 and negative 2. All right, but we can cross out x plus 2. So negative 2 is removable. And 5 is non-removable. So think of the act of crossing it out as removing it. Okay, number 40. We have f of x is equal to x minus 1 over x squared plus x minus 2. So let's see if we can factor. I'm going to tell you, if one of the factors is not x minus 1, it doesn't really do us any good here, does it? So let's see if we can make that work. How about x plus 2 times x minus 1? That'd give us a positive x in the middle and then a negative 2. So our points of discontinuity occur at negative 2 and positive 1, right? Because that's what makes the denominator 0. Negative 2, we can't cross that out. We can only cross out x minus 1. So 1 is removable. But negative 2 is non-removable. All right, lovely. Okay, let's do 41. All right, absolute value, we have to take limits from both sides here with an absolute value. So let's say we have f of x equal to the absolute value of x plus 2 over x plus 2. So where are we going to have a possible discontinuity? Well, we're going to have a discontinuity at x equals negative 2, right? Because that makes the denominator 0. So let's see if it's removable or non-removable. So we would take the limit as x approaches negative 2 from the left first of absolute value of x plus 2 over x plus 2. Well, from the left, that's going to be like negative 1.99, right? Well, you take the absolute value, you're going to have a tiny positive on top. On the bottom, you would have negative 1. Let's see, from the left, excuse me, that'd be negative 2.001 or something like that. So negative 2.001 plus 2, sorry about the confusion. We'll get to that in a minute. That would be over a tiny negative. So remember, from the left, we're plugging in something like negative 2.001 in there. So that's going to be negative 1. And then let's take the limit as x approaches negative 2 from the right. So that's going to be a number a little less negative than negative 2, right? Of x plus 2, absolute value over x plus 2. So that'd be, from the right, would be like negative 1.99. So we'd have a tiny positive on top. And on the bottom, you would also have a tiny positive, which equals 1. So they're not equal. So the answer is we do have a discontinuity at x equals negative 2. The limit does not exist, so it's non-removable. All right. 42. 42 is basically the exact same problem. We have the absolute value of x minus 3 over x minus 3. Okay, so if we have a discontinuity, It's going to be at what number? X equals 3. We need to take the limit from the left and from the right and see if the limits are equal. So x approaches 3 from the left of the absolute value of x minus 3 over x minus 3. The left of 3 would be like 2.99, right? So we'd have a tiny positive. And I could really quit writing tiny, but and 2.99 minus 3 over a tiny negative. So that's going to be negative 1. And if we take the limit as x approaches 3 from the right, absolute value of x minus 3 over x minus 3, still going to be positive on top. That's what taking the absolute value does. But on the bottom, that'd be like 3.001, right? So you'd have a tiny positive on bottom. So that's going to be 1. They are not equal. So the limit does not exist. Therefore, it is non-removable. Okay, let's see if we can squeeze 43 in here. All right, piecewise. So we've got f of x is equal to x. And what a terrible bracket. When x is less than or equal to 1. So from the left, and then x squared when x is greater than 1. So you just have to take the limit of each. The limit as x approaches 1 from the left of x, plug in 1, because you're going to use this one, and it's 1. And the limit as x approaches 1 from the right of x squared, okay, we're going to use this one. 1 squared is 1, right? They are equal. So there is no discontinuity. Right? Plus there's no denominator there, you know, so there's it's not going to be undefined anywhere, but there's also no jump in this function. Okay. So the back of the book on that one, 43, might have said continuous at all points. All right, 45, f of x. Do a little better here. 1/2 x plus 1 when x is less than or equal to 2. And 3 minus x when x is greater than 2. So we want to take the limit as x approaches, could there be a discontinuity? It is at 2. All right, as x approaches 2 from the left, then we use the equation 1/2 x plus 1. Plug that in, 1/2 times 2, 1 plus 1, 2. Take the limit as x approaches 2 from the right. That's going to be the bottom equation, 3 minus x. 3 minus 2 is 1, not equal. That means this has a jump discontinuity at x equals 2. Okay, if we were to graph that, it would jump from 1 at x equals 2. The y value would jump from 1 to 2. So a jump is non-removable. Not a hole that you can cancel out. So the answer is that. But it's also, it asks if they are removable or not. Okay, last one. Got f of x is equal to negative 2x when x is less than or equal to 2, and x squared minus 4x plus 1 when x is greater than 2. So where could we have a discontinuity? It's at x is equal to 2. Let's check and see if they are equal. So as x approaches 2 from the left, x is less than 2 of negative 2x, that's going to be negative 4, right? Limit as x approaches a deuce from the right, x squared minus 4x plus 1. Plug that in. That's going to be 2 squared is 4 minus 8. So that's negative 4 plus 1, negative 3, right? Okay, do I have that? Did I do that right? Double check me. All right, I think so. So those are not equal. So it looks like we've got another jump discontinuity. At x equals 2, and that is non-removable. Woohoo! All right, made it through another solutions video. I will talk to you next lecture.